Students, periodic table arrangement of elements in systematic way is one of the important asset of inorganic chemistry. Study of periodic table is the backbone of the inorganic chemistry. If you go through the standard books, you will find elements in periodic table are divided into three parts. First, main group elements. Which groups are there in main group elements? Group 1 and group 2. Afterwards, group 13, 14, 15, 16, 17 and last 18. All these groups are in main group elements. Second type of the elements is transition elements, and those are included in group number 3, 4, 5 to group number 12. So how many columns are there? How many groups are there in transition series elements? 10 groups are there. Now one more portion is there. One more part of the elements is there, and that part is none other than inner transition series elements. And students, the objective of this course is to make you clear the concept about inner transition series elements. What is meant by inner transition series elements? Where are they located or situated in the periodic table? That we should study. So my expected outcome is you should know the concept of inner transition series elements and their position in the periodic table. Now question arises, in this periodic table, total how many columns are there? How many groups are there? 18. Why are they? Because if you see at the beginning in group 1 and group 2, s orbitals are filled. And s orbital can accommodate how many electrons maximum? 2 electrons. Therefore, 2 columns are there. Afterwards, right side, 6 columns were included right from group number 13 to group number 18. Why number 6 is there? Because in those elements, electrons are filled progressively in which orbital? Right, p orbital. And p orbital can accommodate maximum 6 electrons. Therefore, 6 groups are here. In between those two sets, there are 10 columns because d orbitals are progressively filled there. D orbital has how much capacity? Maximum capacity? 10 electrons. Therefore, 10 columns are there. So total 2 plus 10 plus 6 means how many? 18. Now furthermore orbital is left, which is that f orbital. So as per their trend, we need to make provision for the f orbital. But surprisingly, it is found the location of those f orbital filling element is within this transition series element. Inside the transition series element, they are inner to the transition series element. Therefore, the name inner transition element, and that we are going to study. These inner transition elements are located in group number 3. But if you see that group number 3, which starts with scandium. But after scandium, such elements are not there, as like now we are considering. Below that, there is yttrium. Below that, lanthanum. And after lanthanum, further 14 elements are there, which are included in inner transition series elements. Likewise, actinium, and after actinium, further 14 elements are there. Those are to be included there. So if we have to arrange them in that group number 3 only, then what we need to do? There will be the gap for first 2 rows of the transition series element. Or else we have to prepare 3-dimensional arrangement. Lanthanum followed by the remaining 14 elements. Actinium followed by remaining 14 elements. So it will be somewhat inconvenient to understand, to grasp. And aesthetic point of view also, it will not look good. So only for the aesthetic point of view, those elements, which elements? Remaining elements. So 14 elements are kept at the bottom of the periodic table, called as lanthanoids. Second row, that called as actinoids. In true sense, they are not adding to the period number. They are there only in period number 6. Lanthanum and these lanthanoids. Period number 7, actinium and the following 14 actinoids. So it is only for the arrangement purpose we are representing them down. But property point of view, understanding point of view, the elements in which f orbitals are progressively filled. Means if electrons are not there, then also we need to what consider, because very soon they are going to fill progressively. Then such elements are called as inner transition series elements. How many such elements are there? Total 30 elements are there in 2 sets. The first set, lanthanum, followed by remaining 14. So 15 elements, those are called as lanthanoids. Actinium followed by 14. Those are called as actinoids. And how many are they? 15. Now question arises, why am I saying lanthanoids or actinoids in spite of lanthanide or actinide? See, at the beginning, this lanthanide and actinide, these names were given. But the last letters, if you observe, IDE, IDE indicates a negative ion, as like sulfide, chloride, bromide. So these are not negatively charged ions. These are metals. They prefer to show positive oxidation state. So IDE is somewhat injustice. Actually, the father of modern chemistry, Antoine Lavoisier, has given us such kind of the terminology. But afterwards, considering the argument, IUPAC decided to understand, to label, to term these elements, these groups as lanthanoids or lanthanons, actinoids or actinons. Are you following what I am saying? All these elements are metals. Their general outer electronic configuration is n-2f and number of electrons may be 0 to 14. Then n-1s 2 electrons, n-1p 6 electron, n-1d there may be 0 to 1 electrons, and last cell ns 2 electrons. So total how many shells are there about which we are discussing now as a outermost electronic configuration? ns2, that's the first outermost cell. n-1d, n-1p, n-1s, that is what the pre-outer cell or pre-ultimate cell. Before that n-2f, it is means what? Pre-ultimate cell.
Pre-penultimate
Means these are the elements in which electrons are entered in
pre-penultimate n-2 f orbital.
These elements depend on n-2 f electrons. Therefore, our focus will be in this outermost electronic configuration. If I have to talk the position in the periodic table, then more correctly, in more detail, what can I say? Among inner transition series elements, where two series S are possible, the first series called as lanthanoids or lanthanoids, they are placed in group number 3 and period number 6, and total from lanthanum atomic number 57 to lutetium atomic number 71, 15 elements are there. And second series also belongs to group number 3 and period number 7, in which actinium atomic number 89 to lawrencium atomic number 103. Total 15 elements are there. Now let us compare the lanthanoids and actinoids. Total, I explain this comparison in 7 points. Point number 1, lanthanoids, progressive filling of 4f orbital. Here, progressive filling of 5f orbital. Point number 2, general electronic configuration of lanthanoids, 4f electrons may be 0 to 14. Then 5s2, 5p6, 5d 0 electron or 1 electron, and at last 6s2. And what about the actinoids general electronic configuration? 5f 0 to 14, 6s2, 6p6, 6d 0 or 1 electron, and at last 7s2 electrons. These are the general electronic configurations for lanthanoids and actinoids. Now point number 3. In case of lanthanoids, atomic size decreases, but uniformity decrease in size is not there. But ionic size regularly decreases. And for actinoids, atomic size as well as ionic size regularly decreases, uniformly decreases. Point number 4. In case of lanthanoids, general stable oxidation state is +3. But exceptions are there. +2 and +4 oxidation states also are stable. But in case of actinoids, such generality not there. Main principal oxidation state is not there. from +3 to +7. This wide range of oxidation state is exhibited by actinoids. Now point number 5. In case of lanthanoids, only one element, promedium, is radioactive. But in case of actinoids, every element is radioactive. Point number 6. Lanthanoids have moderate tendency to form coordination compound, to form complexes. Means somewhat weak tendencies there you can consider. And for actinoids, strong tendencies there to form complexes. What may be the reason? Oxidation state, high oxidation state is one of the reason for that. Now point number 7. Lanthanoids generally are represented by term or by symbol Ln, and actinoids or actinons are represented by symbol An. Means when general properties are to discuss, then individually labeling lanthanoid or actinoid is not suitable. So general term should be there. So general term for lanthanoids is Ln and for actinoids is An. As like metal we represent by M. It's a general term, general symbol, general representation. Then not we saying sodium is there, magnesium is there or iron is there. In general way we do represent that. Likewise, it is a general representation. After this introductory lecture, it is a need now to discuss these lanthanoids and actinoids separately. So in next lecture, we will discuss lanthanoids, which elements are included in lanthanoids, and stepwise their property we will discuss. So next lecture, let us know all 15 lanthanoids. I'll give the trick to you to remember all 15 lanthanoids, because if you know those elements, then their chemistry will be the interesting to you. Otherwise, difficult names are there, how to remember. If suspicious approach remain, then chemistry will become difficult. So students, my expected outcome was, from your side, expected learning outcome was general understanding of inner transition series element. Is it fulfilled? Did you got the point about the inner transition series element? Is the concept of inner transition series element clear to you? See you in the next part.